Right. The other type of motion that we like to look at, so there was projectile motion, but the other specific type of motion we like to look at is our simple harmonic motion. What we're talking about is this sort of motion. So all the particle does, it just moves backwards and forwards between 2 points. Backwards and forwards, backwards and forwards, backwards and forwards, but in such a way that its acceleration is always directly proportional to its distance from a fixed point. So that would be the center of the motion. Usually, if it's nice, that centre is zero, it makes life a lot easier. But we call that simple harmonic motion. So I guess if I could illustrate, imagine, yes, I'm at the origin. Now, if my acceleration is proportional to my displacement, at the origin, my acceleration must be zero. Because it's going to equal some constant. So acceleration is proportional, which means it's equal to some constant times the displacement. However, for this to work, that constant needs to be negative. So rather than writing k, I'll write it as minus n squared x, and that ensures I've got a negative constant. Now it has to do that because once I go past the origin, my displacement is now positive. So my acceleration is increasing as my displacement is increasing. But I want to slow down. So I need the acceleration to be in the opposite direction. Because otherwise I'm not going to stop and then come back. So that's why this constant needs to be negative. Okay, so there's the basic rule of simple harmonic motion. They tell me something's moving in simple harmonic motion, then I know it satisfies this. The acceleration is equal to some negative constant times its displacement. All right, let's work with that. Acceleration's in terms of displacement. So I'll go d dx of a half v squared, and I'll come up with a velocity equation. Integrate both sides. Now I need some initial conditions here. Let's make it the simplest that I can. I need one between velocity and displacement. Well, I know it's going to stop at its furthest point. Because remember I said it's just going to move backwards and forwards, backwards and forwards. So out at the extreme point, whatever that turns out to be, that's where it's going to stop and then come back. So conveniently we use A for amplitude. So we'll call it A. So x equals A, that's how far it'll go. I know velocity will equal 0 at that point because that's when it's going to stop and come back. So sub in, and my constant becomes n squared a squared. So I now have the formula. V squared is minus n squared x squared plus n squared a squared, which means v squared, if I factorise it, turns out to be n squared a squared minus x squared. So velocity will be plus or minus depending on which time I'm at there, because remember we're going backwards and forwards. So at one point in time I'll have positive velocity, but then when I'm coming back I'll have negative velocity. Now that tells me some information too, because again if I use the idea that, hang on, I know v squared always has to be greater than or equal to 0, or another way of thinking about it is whatever's under the square root must be greater than or equal to 0. So a squared minus x squared is greater than or equal to 0. So it confirms what I was saying. This will work. Because x will travel between a and minus a. And that's what we wanted. Backwards and forwards between these 2 points. So okay, it's looking good. Now let's find a displacement equation. So dx to t is equal to, now in this case I can pick either one. Because remember the equation, the initial conditions I picked, the velocity was equal to 0 at A. So whether I pick plus or minus doesn't matter, because plus or minus 0 is 0. There is a reason I chose negative though. The reason I chose negative is because my particle is starting at its amplitude. And I suppose I'm picking it because I know how this is going to end up. It's going to be a trig curve. It's going to be a sine curve or a cosine curve. So I want the one that replicates what my motion's doing. Cosine, sine. It's the cosine curve that starts at the amplitude. If you think of drawing a cosine curve, at time equals 0, you're up at the top, the amplitude. So if I've got a problem like this, then if I've got my initial conditions where x is plus or minus a, I'll always choose negative, and therefore when I end up integrating, I'll get an inverse cos curve. If I'm starting at the origin, then we'll go with positive, and that'll be the inverse sine curve, because that's what the sine curve does. It starts at the origin. It just makes life a little bit easier. It doesn't matter if you pick the other one, you'll just end up with a shift, because that's all the difference is between a sine and a cosine curve. They're the same curve, but shifted 90 degrees. I'm just trying to make life easy for myself, make the math nice. So all right, turn it upside down. The t dx is minus 1 on n square root of a squared plus x squared. I'll do this as a definite integral. So the integral of the t from 0 to t, we're saying when time is 0, I'm out at my amplitude. So I want to link t and x. I've got minus 1 on the square root of a squared minus x squared. That's why I chose the negative, because now I can just say inverse cos. So that's inverse cos of x on a. Okay, we want to make x in terms of t. And inverse cos of 1, of course, is 0. So there's 1 on n inverse cos x on a. Multiply by n, I get nt. Well, I want to make x the subject, so find the cosine on both sides to undo that inverse cos function. And there it is, there's our trig curve. X equals a cos nt, a nice, neat little curve. In general, they tell me it's simple harmonic motion, then I know it satisfies acceleration as minus n squared x. This one, v squared equals n squared a squared minus x squared, it's one of those ones that gets huge arguments about can you quote it or can't you quote it. I personally say, in general, no, and you don't need to, because you can get it all through just integrating anyway. But that allows us also to find the path of the particle, because we can say v squared is greater than or equal to 0, solve that. We'll end up with a cos nt, or of course, had it been the one where we started the origin, we might end up with a sine curve. And so a is the amplitude. And now we're just dealing with trig functions, which we've already done a fair bit of work on. So we know the particle then would have period 2 pi on n. There's another term we talk about with simple harmonic motion, that's frequency. And all frequency is the reciprocal of period. So if you want to work out the frequency, reciprocal. So period is basically the time for one oscillation. So one complete backwards and forwards. Right? So that's whereas frequency is the number of oscillations per time period. So whatever units you're working in, usually seconds. So frequency is how many oscillations in one time period. So that's the difference between the two. So here we are. This time they've given us the displacement formula to start off with. One of the things they like to, when they start with displacement, one of the things they like us to do is, oh well, go and actually prove, go and show it's simple harmonic motion. Now, you don't need to do a heck of a lot, because all we have to do is show it satisfies negative constant times displacement. Acceleration is negative constant times displacement. So I'm just going to differentiate twice with respect to time. And if we have a look at that, well, displacement was 4 sine 3t. So there it is. Acceleration is minus 9x. It is negative constant times displacement. So yes, that satisfies simple harmonic motion. So that's good. Now, if there's a shift happening, then all you would do is show it's minus 9, and then in brackets you might have x minus 3 or x minus 2, whatever. That's still simple harmonic motion. Essentially, though, the coefficient of x is the key here. That's got to be a negative number. Okay, said find the period. Well, minus n squared x, so I know n's 3. Or I could look at my simple trig function, and we know period is 2 pi on the coefficient of t, so 2 pi on n. So either way, I get 2 pi on 3 seconds. Well, I didn't actually state this one was in seconds, did it? Okay, I'm making an assumption there. Find the interval in which the particle moves. I'm not going to do a whole heap of calculus to do that. This is what I mean. You don't need the v squared one. If I've got the trig formula, I just use my knowledge of trig. I know 4 sine 3t goes between 4 and minus 4. I don't have to do any fancy calculations. So all right, it moves between minus 4 and 4. What is its greatest speed? And hopefully they'll say speed rather than velocity. We don't have to worry about, oh, hang on, is negative bigger than positive, and so on. Speed. Well, there's my velocity. It's a cosine curve. The biggest that's ever going to be is 12. Bingo. There's my greatest speed, 12. So this one starts with acceleration. And now it wants us to find the interval. So again, this is the one where some people go, oh, I'll just quote that v squared equals n squared, etc., etc. Whereas I'd say with this one, well, I'll just go to v dx. Separate the variables. They told us when x is 3, velocity was 6. Notice, instead of half v squared, I multiplied the other side by 2 there. And there it is. That's the formula that people are sort of quoting. V squared equals n squared, but we've just derived it. I just personally prefer to derive it. Maybe I'm just strange. But v squared is greater than or equal to 0. So there's the path of my particle, minus 3 root 2 to positive 3 root 2. Greatest acceleration, well, there's our formula. Acceleration is minus 4x. So the greatest acceleration must happen when displacement's greatest. So sub in 3 root 2. I've ended up with minus 12 root 2. I'm going to say positive 12 root 2. That'd be what it is at the other end. I mean, it's the magnitude we're worried about here. So 12 root 2 centimetres per second squared in that one. So there's basically the path of our poor little particle. Out of the amplitude, that's where velocity is going to equal 0, but it'll also be where acceleration is a maximum, because it's proportional to displacement. Whereas at the centre, velocity will be at a maximum at the centre, but acceleration will be 0. Acceleration will be 0. So 3D, 3F, with 2 we look at.